Hi all, today I'll be walking you through a statistical data analysis process using Python. We have leveraged the power of libraries such as Pandas, Seaborn, Stats Model, Scikit-learn, Matplotlib, PyPlot, etc. to derive insights from a health insurance dataset. This is done in reference to the discussion question 3 that is assigned to us in the class. Now let's get started. Our first step is loading the dataset. We are working on health insurance data that includes information about the insured, like age, BMI, number of children, smoking habits, and the charges they incur. By using Pandas library, we have loaded the dataset and read it. Since the dataset is in the format of CSV file, read CSV has been used. Now let's take a peek into the first few rows to get ourselves familiarized with the structure of the data. So we have used data.head to get the first 5 rows of the dataset. And we can see that the age 6, that is the gender, BMI, children, smoker, region, and charges are the columns of our dataset. Once our data is loaded, our next step is to get general sense of it. We calculate descriptive statistics such as mean, median, and mode for our key variables, allowing us to understand the central tendencies. This gives us a holistic view of our dataset, helping us to understand average values, spread, and common data points. For that, we have used data.describe, which gives us a statistical summary of all the variables, only the numeric variables, not the categorical variables, since we can't find count, mean, median, mode for categorical data. We can only find it for numerical data. So we have got the statistical summary for numerical data. In order to make our analysis more robust, I have conducted some pre-processing tasks. For instance, we have converted one categorical category, that is smokers, to numerical category. Additionally, I have also standardized some of our variables, ensuring that they are on the same scale, which is important for certain statistical methods. So here I have copied the same data into DF insurance and converted smoker into smoker num, where yes means 1 and no means 0. And I have also standardized age, BMI, children, and smokers. Now we are gonna find skewness and kurtosis. To understand the distribution of our data, we have calculated these two. Skewness tells us about the asymmetry of our data distribution, while kurtosis gives us the insights into the tail of our distribution. This helps us understand if our data follows normal distribution or is there any potential outlier. So for skewness, we have used dot skew method, and for kurtosis, we have used dot kurtosis. Further, we are calculating composite reliability, average variance extracted, and validity to check the relationship between the variables we have selected. Now, I also was curious whether these variables are correlated with each other and to what extent. For that purpose, I have also created a heat map for all the numerical variables. And it looks like so. The red part indicates that they are completely correlated in a positive way. The blue part indicates that they are correlated but in a negative format, and the gray would indicate that they are not correlated at all. I have also selected 2 variables on which I have done a part of descriptive and predictive analysis, that is the age and charges, because I found that they are most positively correlated among all the variables, though smoke, num, and charges are more closely correlated. But smoker num is something that I have created from the categorical variable, so I don't want to use that. I want to stick to the variables that were numeric by their original format and wanted to calculate that. So I have also calculated these two separately here, and this is the descriptive analysis, skewness, and kurtosis of age and charges. Now, I'm jumping to linear regression, where uh, this is our one key analysis. We use the OLS method to predict insurance charges based on factors like age, BMI, smoking habits. This allows us to understand which factor is significant predictor and the nature of their relationship with the charges. Okay, here I have also created one more visualization, that is actual versus predicted medical charges, which means that if the predicted charges are somewhat near the actual charges or they are completely deflecting from the actual charges, so we can see that they are close to the actual charge except for this one, but they are really close. These are somewhat far from the actual, but not way too far. Now, this is the OLS regression result we got from the analysis, that is our model. Further, we are going to calculate the path analysis. We are going to get their path coefficient to understand how closely they are related, even though we have heat map, but path analysis would give us more clarity over it. So we have also touched upon structural equation modeling through, though it's in simplified form. We looked all the factors leading to understand uh, whether they are the weightage of the observed variables on the latent variables, their relationship. We also calculated the composite reliability average variance extracted to ensure our model's reliability and validity above. To make our analysis more interpretable, we have again used a visualization, as someone has rightly said, that a picture is worth 1,000 words. Here we are again trying to understand the interaction of age and BMI on medical charges, where blue line will indicate BMI 24.57, orange will indicate BMI 30.66, and green would indicate 36.76. So to sum up all my analysis, our analysis has provided key insights into the factors affecting health insurance charges, which can help in making informed decision to the analyst or whoever is in need of. Thank you very much for listening to me for the video.